We're going to attempt to solve this rational inequality. The first step is to get 0 on one side of the inequality. So I'm subtracting 1 from each side so that I have 0 on the right. I'm going to have to eventually get common denominators, right? I can't put these two parts together because they don't have the same denominator. Lucky for us, there's an easy fix, right? So what I'm going to do is I'm going to multiply by the denominator over itself. So I'll multiply by 2x plus 4 over 2x plus 4. By doing that, I'll have two separate fractions, each of which has the denominator 2x plus 4. So what I can do now is combine them. X minus 4 minus 1 times 2x plus 4 all over 2x plus 4. And that's greater than or equal to 0. We'll distribute that -1. And right now we're trying to combine all the stuff on top, right? So we have a simpler expression. So -1 times 2x is -2x, -1 times 4 is -4, and all of this is over 2x plus 4, right? We need that to be greater than or equal to 0. We'll combine these like terms, right? X minus 2x is -x, and -4 minus 4 is -8. Again, all over 2x plus 4, greater than or equal to 0. And to be honest, at this point, we actually have enough where we could find the critical values. I'm going to take it one step further. So I'm factoring a negative out of the numerator, and I'm also going to factor a 2 out of the denominator. Notice when I factored it, it's still out in front, right? I basically divided -x by -1 and got positive x, divided -8 by -1 and got positive 8. Similar thing happened down here with a 2x plus 4. Okay, so that expression is greater than or equal to 0. I now have my critical values of x. Those are the things that make the numerator or the denominator 0. So if x is -8, the numerator is 0. If x is -2, the denominator is 0. I'll list the multiplicities of those critical values now, and we'll talk about why later. So since the factor x plus 8 only shows up once, right? Look top and bottom, I only see it once. It has an odd multiplicity. If it showed up 3 times, we'd also say odd multiplicity. If it showed up 4 times, we'd say even multiplicity. So same thing with 2, right? -2 shows up once, it's odd multiplicity. And behavior, there's this memory technique. Odd gives opposite, even gives equal. Again, we'll talk about what this all means in a little bit, right? Opposite. So I'm just listing this for later. Once I have my critical values listed, I'm going to draw a number line and put my critical values on there, right? I'm going to plot them on my number line. So I'll start at -10, try to paste this out nice and evenly. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And that should be good enough. There's my -2. There's my -8. I'm putting a circle over each of them. So what do I do with the circles? If it comes from the denominator, as -2 did, right? I look at -2, I go, ooh, that came from the denominator. Stays open. Means you can't include it. And we know that, right? It's a domain restriction. There's no way it's going to be part of an answer. Now, -8 came from the numerator. And since this says or equal to, right? I look at that inequality symbol. From the numerator, inequality symbol says or equal to, I shade it in. So I'm kind of setting myself up for getting an answer here. Once I've got my number line set up with my critical values identified, I pick a test value. So I'm picking 0. I use that anytime I can. I use 0. It's a lot easier to do the arithmetic. And what I'm doing is I'm evaluating for 0 down here. I'm plugging in 0. Now the big thing here, the time saver, is we don't care the size or the magnitude of the number. We just care about the sign. whether it's positive or negative. And so I've got a negative, and 0 plus 8 is positive. Now obviously 2 is a positive, and that's going to be multiplied by 0 plus 2 is a positive. So I get negative times a positive is a negative, positive times a positive is a positive, and anytime I have a negative divided by a positive, my end result is a negative. So where that test value was, that whole section is going to be negative. So here comes the multiplicities stuff. That critical value of -2, when I cross over that critical value, I need to make sure my sign is opposite, right? -2 had an odd multiplicity, so it forces an opposite sign. So if it's negative on the right, that means it will be positive on the left. Similarly, when I cross over the critical value of -8, if it's positive on the right, it's the opposite sign, or negative on the left. You are more than welcome to test other test values and just to verify that those are right, but I assure you it works every time. So the final thing now on our graph is to identify whether we want the negatives or the positives as our solution set. This fraction over here says it must be bigger than or equal to 0. That means greater than or equal to 0 is positive numbers. And so I'm shading in on my number line where I'm shading the interval that had the plus sign above it. Right, you see that? Shade in where the plus sign is. So I've got my solution set identified graphically. To write it out, I'll just label it solution set. To write it out, it's pretty quick, right? All I have to do is copy that -8 and the -2 because it's actually between those. For interval notation, I'll put a comma between them. If I include the value, as I do here for -8, I put a bracket. If I don't include the value, as I have an open circle with -2, I put a parenthesis. Now I will say, anytime infinity is included in your solution set, remember it's not a number, so always use a parenthesis for infinity. To write this in what's called set notation, this is the one or the notation that you're more familiar with. We again copy down the -8, copy down the -2, and remember all the x values are in between them. Since I have them listed from left to right, I use less than. Numbers are less when you move to the left. Again, numbers are less when you move to the left. That's why I'm using that less than symbol. If you include the value, add in the or equal to. See it? Include, add in or equal to. If you don't, if it's an open circle, leave it as is.